Okay. All right. Not even sure if this works for us right now, but we're going to take a look. Comparing decimals. Among the galaxies closest to Earth, M82 is about 1.15 times 10 to the 7th light years away, and Leo the 1 dwarf is about 8.2 times 10 to the 5th light years away. Which one is closer? So which one is closer would be the smaller number, right? So we got to take a look, compare our exponents. 1.15 times 10 to the 7th, is that going to be larger than 8.2 times 10 to the 5th? Now you think because 8.2 is bigger than 1.5, 8.2 is going to be larger, but you're wrong. Because 10 to the 7th is 1 with 7 zeros, and 10 to the 5th is 1 with 5 zeros. So we can look at that. We've got, it was here, right? If I move 11 spots over, I've got 11,500,000. And if I head to 8.2 and I move it 5 spots over, it's 820,000 light years. So obviously 11.5 million, 11,500,000 light years is a lot more than 820,000 light years. Okay. So all I really need to do is compare these two little tiny numbers. Let's try it again with a really small number. Okay, the average lifetime of a tau lepton, that's an element, is 2.906 times 10 to the negative 13 seconds, and the average lifetime of a neutral pion is 8.4 times 10 to the negative 17th. Explain which subatomic particle has a longer average. So we got a tau lepton and a neutral pion. They are subatomic particles, but they don't last very long. So I'm going to compare these numbers. Which one? This is 2.9, this is 8.4. You're going to think 8.4 is bigger, but we've got 10 to the negative 13 and 10 to the negative 17. Which exponent is bigger? Negative 13 is bigger than negative 17, right? So we have to take a look at this. We can take a look. Here's the 13 decimals, here's the 17 decimals. So obviously 17 decimals is smaller. If we look on our number line, every number to the right is bigger, right? 0 is bigger than negative 1, is bigger than negative 2, etc. So negative 13 is bigger than negative 17. Compare these two. Which one do you think is bigger? Our magnitudes are exactly the same. So I'm going to compare 9.3 and 9.2. So this one's going to be smaller. Okay. All right. There you go. So when comparing numbers in scientific notation, compare the exponent. The larger exponent is a larger number. If they're the same, then they're the same.